All right, so suppose we have quadratics that will factor, but we're not able to um, figure out what the factored form is. So you can always solve these using the quadratic formula, even if you can factor it, even if it's factorable. So I just want to go through a couple of these examples. We just did these in a previous video, so you know they can factor. But what does it look like to solve them if we don't factor? What does it look like if we use the quadratic formula? So the first thing we want to do is get it in standard form, which is what this is. A is 6, B is negative 24, and C is 0. So then we're going to replace B with negative 24, and A is 6, and C is 0. So then we do it one step at a time. Our x is equal to 24 plus or minus the square root of, and 24 divided by 24 squared is 576. I'm not sure. 576 it is. And then this is minus 0 all over 12. So then x equals 24 plus or minus. We know the square root of 576 is 24 because we just did it, divided by 12. So we get two solutions. We get 24 plus 24, which is 48 over 12, which is 4. And then we get 24 minus 24, which is 0 over 12. So that gives us a solution of 0. So that is our first solution. And you can see how it matches the solution that we got here, 0 and 4. Now we're going to move over to difference of squares. Suppose you can't factor difference of squares. So you can use the quadratic formula with A equal to 25, B equal to 0, and C equals 49, negative 49. So then 0 goes in place of B, and 25 goes in place of A, and negative 49 goes in place of C. So we end up with x equals 0 plus or minus the square root of 25 times 49 times 4 is 4,900. And all of that is over 50. And then the square root of 4,900 is 70. So we get 0 plus or minus 70 over 50. So we get 70 over 50, or 7/5 as one solution. And we get negative 70 over 50, or negative 7/5 as our other solution. And you can see that that's exactly what we got here when we did it by factoring. Then you have trinomial factoring when A is 1. These are usually pretty easy to factor, but if you can't factor them, then you identify A, B, and C, and you substitute in. B is negative 4, A is 1, C is negative 12, and you simplify. 4 plus or minus the square root of 16 plus 48 all over 2, which is 4 plus or minus the square root of 64 over 2. Notice each one of these, our radicand, the number under the radical, has ended up being a perfect square. 64 is a perfect square, 576 is a perfect square, 4,900 is a perfect square. So then this ends up being 4 plus 8 over 2, which is 12 over 2, which is 6, or 4 minus 8 over 2, which is negative 4 over 2, which is negative 2. And that's exactly what we got up here when we solved it by factoring. And then finally, the last one. These are a little harder to factor when that A value is not 1. So sometimes this might be the easiest way to do it. A is 3, B is 8, C is 5. And we're going to substitute in 8 for B, and 3 for A, and 5 for C. So we get x is equal to -8 plus or minus the square root of 64 minus 60 all over 6, which is -8 plus or minus the square root of 4 over 6, which is -8 plus or minus 2 over 6. -8 minus 2 is -10 over 6. -8 plus 2 is -6 over 6. So our two solutions are -1 and -5/3, which is exactly what we got up here when we solved it by factoring. So you can always use the quadratic formula to solve, but sometimes it's easier to factor if your factoring skills are pretty solid.